Right, let's discuss questions from quiz. So figure 1 here shows a 2.5 kilogram block connected to a 2 kilogram load by a light string. So the pulley is negligible, has negligible mass. The coefficient of kinetic friction between the block and the table is 0.18. And when the system is released, we have to calculate the acceleration of the block, tension, as well as total kinetic energy of the system after it has moved 0.6 meter using the work energy theorem. And then lastly, we have to find the final velocity of the block. Right, so I've drawn it like this. So first we have the information. What information do we have? It's just the coefficient of kinetic friction, which is 0.18 lah. Okay, right. Now we have to draw the free body diagram lah. Okay, so let's draw free body diagram. This is for the 2.5 kilogram block, and then another one is for the 2 kilogram block. Okay. Let me use this. So for the first block, the 2.5 kilogram block, it has mass, and then it is in contact with the surface, so it has a normal force. Lepas tu, it is not frictionless surface, so it has friction opposing the motion of the block. And then there is a string, so there is a presence of tension lah. Okay, so that is for the first block. The second block, it only has weight and then the tension. Okay, so itu sahaja for the free body diagram. So this is M1G, this is tension, this is the normal force, this is friction force. Okay, lepas tu yang ini dia just ada the weight and then the tension. Okay, so that is your free body diagram lah. Okay, now we have to find acceleration of the block. So the acceleration of the block, we can use the chapter 4 punya formula. So total force at x is equal to m1a. So we are gonna look at the first block dulu. Ini sahaja. Ini jangan dulu tengok. Ini dulu. Okay. So now the force at x is acceleration is going to the right. So any forces that is going to the right will be positive. Okay. So T will be minus dengan Fk equal to M1A. Okay. Okay, lepas tu we know that F is equal to mu Kn M1A. So this is our first equation. Okay, lepas tu we do for total force at Y. Sama juga untuk block block 1, which is 2.5 kilo per block, equal to 0. N minus M1G equal to 0. So N is just M1G lah. Okay. Okay, lepas tu we have to see for the second block. So ini lagi. So this is just at the Y component. So total force at Y is equal to M2A. So the acceleration is going down, pointing down. So any forces that is pointing down will be positive. Okay. Alright, so M2G minus T is equal to M2A. So tension is M2G minus M2A. So this is equation 2. Right? So substitute N and 2 into 1. So we have T minus mu K N is M1G equal to M1A. Oh, I forgot to substitute. So M2G minus M2A minus mu K M1G equal to M1A. Okay? Boleh ah? So now we are gonna find, we are gonna let acceleration 2 to be the subject lah. Okay, so m1a plus m2a equal to m2g minus mu k m1g. Okay, yang ini I've rearrange it to pindah pergi sini, so dia jadi plus m2 plus m2a. Okay, right, so this one can factorize m1 plus m2 equal to m2g minus mu k m1g. So acceleration is m2g minus mu k m1g m1 plus m2. So ini dia punya equation. So just substitute, you should get acceleration to be equal to 3.38 meter per second square. Okay, right, so that is your solution for question Roman 1. Okay, lepas tu for Roman 2 dia minta tension in the string. So tension in the string, we can just use equation 2, which is T equal to m2g minus m2a. So you should get the tension to be equal to 12.86 Newton. Okay, okay, now we have to do question Roman 3. So for Roman 3, we have to use work energy theorem to find the total kinetic energy after the block has moved 0.6 meter. Okay, so mesti guna work kinetic energy theorem. Kalau tidak akan dapat markah lah. Okay, so work kinetic energy theorem is work equal to the change in kinetic energy. And then the displacement is given, which is 0.6 meter. Okay, and then we know that work can be calculated using this formula. Cos theta equal to kinetic energy final minus kinetic energy initial. So basically, initially the block does not move, so we are gonna have kinetic energy 0. Yang initial is 0 lah. Okay, right, so now the net force is just the x component, T minus Fk, not just the x component lah. I mean the one that is in motion, sorry. So T minus Fk S cos theta plus lagi dengan yang in motion, which is ada dua in motion, x component untuk the first block and the y component for the second block. So we have to add this both together, okay, untuk cari the net force. So the net force untuk yang second block is m2g minus t s cos theta equal to kinetic energy final. Okay, so you should actually just get the value after substituting the numbers lah. Tulis ya. So T is 12.86 minus mu kn. Alamak, mu. I'm just gonna directly write this one here is mu kn, which is equal to mu k m1g, I think. Is it that one? Dia dari yang ini, so dia akan jadi this one. Okay, betul. Mu k m1g, so mu k is 0.18, mass dia 2.5, 9.181. Okay, lepas tu S is 0.6, cos 0 degree lah. Okay, why cos 0 degree? Sebab dia follow the direction of the displacement lah. So this one is 2, 9.81 minus 12.86, then 0.6 cos 0 degree. So you should get the final kinetic energy to be equal to 9.12 joule. Okay? Alright. That is how you solve using work kinetic energy theorem. Lepas tu, the last question, we have to find the final velocity of the block. So the final velocity of the block, we can actually use the value of kinetic energy yang kita dapat tadi. Just add both the masses together lah. Sebab this kinetic energy ni, I mean this value of kinetic energy 9.12 joules is for both blocks. Okay, it's not for block 1 sahaja. No, it is for both of the blocks. Okay, so this is v square, and then 9.12 equal to half 2.5 plus 2v square. So you should get the final velocity of the block to be equal to 2.01 meter per second. Okay, so that is the solution for question number 1 of our quiz on chapter 5.